Good day, everyone. Welcome back to Leetcode Simplified. I'm Alan, and in this episode, we're walking through the solution to Leetcode 234 Palindrome Linked List. Given the head of a singly linked list, return true if it's a palindrome, meaning it reads the same forward and backward. For example, linked list 1, 2, 2, 1 is palindromes because it reads the same both ways. However, linked list 1, 2 is not a palindrome, since reading it forward gives 1, 2. Reading it backwards gives 2, 1. They are different. Now, the first easy, straightforward approach that comes to mind is to copy all the values into an array. Then check if that array is a palindrome. That works, but the array consumes big O of n time extra space. We can do better. Let's design an algorithm that runs in big O of n time and use only big O of 1 space. Our solution comprises of 3 phases. Phase 1. Find the start of the second half. Phase 2. Reverse the second half. Phase 3. Compare both halves node by node. Let's look at it in details in Python. First, we start by creating 2 pointers, slow and fast, pointing to the same node as head. While fast and fast next are not none, do. Advance slow 1 step. Advance fast 2 step. Advance slow 1 step. Advance fast 2 step. If the linked list has even nodes, our loop will stop when fast ends at none. Slow will be at the start of the second half of the linked list. We then proceed with phase 2, reverse the second half using the classic 3-pointer technique, brief, slow, and NXT. First, set brief points to none. Then, while slow pointer is not none, do. Set an XT pointer points to slow next. Revert slow next pointer. Advance brief. Advance slow. While slow is not none, repeat. Advance NXT. Revert slow next. Advance brief. Advance slow. When slow is none, loop ends. Brief will point to the head of the revert second half of the linked list. We then proceed to phase 3. Compare the first and second halves, node by node. Set left to be the head of the first half, right to be the head of the reverse second half. Then, while right pointer is not none, do. If left value differs from right value, return false instantly. Otherwise, advance left and advance right. If every pair of nodes match, the linked list is a perfect palindrome, return true. In our case, the first half linked list 1, 2, the same as our reverse second half linked list, also 1, 2. So our original linked list is a palindrome. Now, look at the special case when our linked list has odd nodes. Our loop will end when fast stops at the very last node, not none. Slow will be at the very middle node. In that case, we need to skip the middle node by advancing slow to the next node, which is the head of the second half. Okay, we just handled the special case for the odd length linked list. And now everything is all set. Let's hit the submit button and see the result. Moment of truth. Boom, accepted. The time complexity is big O of n, since we traversed the linked list a couple of times. And space complexity is big O of 1 constant, no extra space, just pointer juggling. And that's it for today. We just checked if a linked list is a palindrome in place. Another elegant trick for your linked list toolkit. If you enjoyed this walkthrough and want to keep sharpening your Leetcode problem solving skill, check out my other playlist right here on the channel. I'm Alan, and this was Leetcode Simplified. Thanks for watching. I'll catch you in the next video.